Welcome to secondary steel making course. Today I am going to speak about mainly the changing the ladle in the case of tundish steel making process. In the previous lectures we were talking about tundish design, tundish metallurgy, steel making process. What is the important parameter design with respect to the tundish was discussed. To know more about the details of this process, you can refer this NPTEL lecture also. Now let me speak about while you are changing to new ladle in the case of tundish steel making process, there is a chance of inclusion level increase. It is mainly because of the following factors. When you are changing the ladle in the case of tundish steel making process to new ladle, the slag which was there in tundish may be carried forward to mold and into the casting also. There is a chance. And the another thing is, when you are changing the metal, molten metal height, so in the tundish, in the transition period, it slowly decreases because incoming flow from the ladle is stopped temporarily since you are changing into new ladle. So that may also causes that height of the molten metal in the tundish may decrease, so that particular slag sulfide particles may entrap into the casting. Finally there may be a situation that the tundish slag will also find its own way and enter into the molten metal, and that particular slag will give you the, instead of clean casting, you will be getting the some more inclusions and impurities entered into the casting with the form called as with the formation of vortex in the mold. And coming to the one analogy, when you are changing the ladle to another new ladle, for example, see this situation. This is the composition 1 and another composition 2 of, this is for the second ladle, this is from the first ladle composition. And I can also use this y-axis for the depth of the tundish bath and weight of the molten steel. For example, this is the composition range from year to year. This is the composition range 1 for the old ladle, composition 2 for the new ladle, and this is the bath depth height, and this is the total volume. This total area will give you the total weight of the molten steel. And for example, at T0, at initial stages, when you are using the one ladle, there will be steady state flow in the tundish is maintained. At this particular stage, T is equal to T1, this is T is equal to T2, please make a correction. At T1 you are going to change into new ladle. This particular bath depth in the tundish slowly decreases. This is one indication. When the new ladle is being taken and incoming flow is started, again this bath depth of the tundish will increase and constantly maintained. This much change will occur in the transition period. T is equal to T1 to T2. And composition, the first ladle composition, because of the atmosphere gases, composition change occur from old ladle to new ladle. This much change may occur. Another entrapment of foreign particle may occur. After this, constantly there will not be change of the composition. Whatever the slab billet you are going to get, at this transition stage, initial stages, mixed composition you are going to get. After that, there will be a steady state composition, slab, billet, boom, casting we will get. This is with a clear detail. For example, T less than or equal to 0 in the previous graph, there will be steady state operations will occur with the incoming flow from the ladle, outflow from the turn dish. Where the t time is between 0 to t1, there is no incoming flow from the ladle, since you are going to change into the new ladle. So there will be a decrease in the turn dish height, and when t1 is equal to t2, when the new ladle is taken at the t1, again increase in incoming flow from the ladle, from new ladle increases, bath depth increases, and residual amount, that particular time gap is covered. And T2 to T3, again it goes to the steady state flow with the incoming and outflow. And after T3 there will be a steady state operation, you will be getting the new composition slab or bloom. At this stage there will be a mixed composition slab or bloom is going to be produced in this particular situation. Now let us observe about few different steel plants, A to F different steel plants, and rate of molten metal flow from the turn dish to mold 3 tons per minute, 2.2, with varying various plants. Number of strand, when a single strand and single mold is used, what is the situation, and 4 strands kind of delta shape, 3 strands kind of T-shaped turn dish is used, what is the situation, and slip depth mainly maintained 1 feet constant, which is called submerged depth into the mold, and the strand distance, one strand to another strand, the nozzle, the distance is maintained from the plant to plant also is different. This will be why it is called dimensionless, is constantly it is been maintained. If it is 0.2 meter, it will be 0.2 meter for the all the distances, depth and distance between the one strand to another strand. After the mold, the strands which are maintained, it is constant. There will not be a fixed distance, this much distance you need to maintain. That's why the fixed dimension is not been provided. These are the various statistics one need to remember for slab and bloom casting through turn dish system. And few more parameters, the capacity of turn dish when it is single strand slab production system is used as a turn dish, 32 tons, 37, 28 industry, it has been practiced from the ABC plants, and surface area of that particular molten metal, volume of the molten metal, and normally how much time the residence time, it varies from the plant to plant, 10 minutes, 16 minutes, and surface area to volume ratio will be different. If it is multi-strand, it will be few more different parameters used. Multi-strand in terms of 3-strand, 4-strand system, you need to use multiple molds. These are the various statistics to get an overall idea in the industry how the turn dish metallurgy to finally casting is being produced, what are the parameters used. It may be the important for the gate examination viva questions. Please make a note. I am taking one of the numerical problem example for the turn dish steel making process. This liquid steel contained in the ladle is assumed that 44 tons, and the residence time is 54 minutes with using 3-strand delta shape turn dish was used in one of the industry. The steady state depth was maintained, there was no change of the ladle, and this steady state depth is around, for the stud depth is 0.8 meter, and you are going to calculate what is the strand opening or strand diameter, and using there was a usage of stopping rod. So, and there was another information is given that for that opening discharge coefficient value is given, density of molten metal is also given. You are supposed to calculate strand opening diameter. What is that? Some amount of theoretical information is required. Mass flow rate from the strand is being given when you assume the unique velocity and cross sectional area. This is liquid density, this is area of the nozzle strand opening, and this is discharge diameter, this is the volume of the molten metal. This is mass flow rate, m superscript 0. From Bernoulli's equation we know that velocity can be interpreted with respect to the gravity and height of the molten metal flow or height, and thus it can be changed. Instead of volume it can be changed, this velocity will be changed into with this parameter. Now the flow rate can be calculated. Since it is a velocity, the total tons, 44 tons is equal to 44,000 kgs, and 54 minutes time as it has been given in terms of seconds, 54 into 60 seconds. Finally you are going to get the flow rate or velocity, average flow rate is 13.8. Since it is a 3 strand system as it is been given in the problem, you need to divide by 3. That means from one strand opening the flow rate is 4.526 kg per second and divided into 3 strands. And now calculating m naught, this is also calculated now, just now, m naught, and density of the liquid and discharge diameter, height is been given. Now when you substitute all these things in the previous formula, you will be getting the area of the nozzle 2.18 into 10 to the power of minus 4 meter square, and the area is corresponding in terms of cylinder 5 by 4 d square, and 5 by 4 d square is equal to 2.8 into 10 to the power of minus 4. But I need to know the nozzle opening diameter d. So yeah, I will be taking this into the LHS side, this will be RHS side. This 5 by 4 is divided denominator, and this square is gone into the right side. This will be the half. Okay, and 1 by 2 becomes 1 by 2, and finally the opening of each strand is comes to be 16.6 is in terms of mm size, 16.6. These things one need to keep in mind. Thank you.